I'm going to get going. I understand that with everything going on in our schedules. So I'm going to do this. This is all will be provided later on the website, and you can access it at any time. I'm going to talk about 3D printing and prototyping and design, and we're going to talk about how to do stuff around making. In my fourth PD, we're going to talk about learning from necessity. Now, we had talked about learning from collaboration, teamwork, and failure and communication, but now we're going to get into the design. So we've gone production, collaboration, communication, and now we're getting into the design. So again, STEAM, the science, the technology, the engineering, the art, the mathematics, all integrated. When I do my STEAM presentations, my STEM classes, everything is integrated. Nothing is separate as we go. Now, today, just like my other PDs, we're going to focus on defining STEAM. I'm going to give you links to subjects, your science, your math, your language arts, how they would integrate with them. We're going to look at practical tools. So I look for online free tools that we can use. And then I will try to go and show you how you can apply it right in the classroom. The STEAM curriculum that I focus on, I go from fourth all the way to lifelong. Right now, I've been focusing on what I do, the fifth, sixth, seventh, and eighth. I will add the ninth and 10th, and I will jump back to fourth too as well. So we have a complete kind of what you can use in your curriculum. So first PD that I did was collaboration, was level 1, teamwork, and we focus on how to work together. Students learn how to do roles and how you pick group mates and how do you work together, how you define who does what. In second level, sixth grade, we work on digital communication. And same thing, we work in groups, but now we're doing asynchronous group. We're doing them at different times. And we use Lego robotics for coding and how to communicate that way using video and audio to talk to show the work that you're doing. Last session I did was on production, which was learning from failure. And it's, again, we make skateboards. So we learn how to learn safety of tools, working with others in the same facilities, working around that type of a project. Today, we're going to focus on design. How we incorporate the prototyping and design into the classroom. I try to add some authenticity to it as well, and I'll show you kind of how we do that. Any questions? Let me check the chat. I don't see any questions in the chat. We're moving on. So in learning from necessity, we focus on the design process. So we're going to basically learn, okay, how do you design? Now, we learned some tools in this. I use 3D printers and I use some modeling software, but we learn how to do some design in this. And then in that, we use the make and take model. So they earn print time, or they earn time to work on a project for themselves. So we find customers, and now we're kind of, rather than just creating something for Mr. Kelly's class, we're creating something for someone else. We go and build it, and then we actually earn stuff for ourselves, our own print time, our own access to my tools or my different equipment that I have. Now, the tools, I am platform agnostic. As I've always said, most of these are either free or they're web-based. I try to show a variety. Some work on Macs or PCs or Apple's Windows machines. Some just are Chromebooks, but a lot of it is open source or open. It's on the web. It works on the web. And we're going to talk about Tinkercad and SketchUp and Fusion 360. We're going to talk about that OpenSCAD, the modeling software we use. We'll talk about slicing software, FlashPrints, Cura and Kiramoto, and I'll talk about Google Earth as well, how I use that. The practical applications that I will use, I use Classroom, I use Forms, I do some 3D modeling software, grabbing some imagery software. That's the practical application. So the workflow management, as always in the last class, I use a Google Classroom. So if I click on this link, you'll see it. There we go. So I'm in my classroom. In here, the kids will get all their work. So as we go through, they do the different activities. Their Tinkercad design is here. Their tutorials are all in here. The videos on how to do things are here as well. 3D printing, prototyping, and design. And as I go along, I'll try to show some different things as how we do that. But if they click here, and in this tutorial, you'll see this is where they click the links to go to the tutorial in Tinkercad. And here I have Google Forms for them to actually hand stuff into me. So here's where they give me the actual file of the work that they did. First, we do screen capture, and then down the road, they give me the actual file so we can use it in the project to print. This is how they join the class, and we'll talk about that in a second. They have a teacher keychain that they give. Same thing, I use a Google form, and this is how they hand the actual file into me. They do their own, and they do a teacher pass too as well. That's a make or take. So we find a projects, things around school that need to do. So they make a pass for a teacher. The teacher is their customer, approves it, and then they get a chance to do it. And I'll show this a little bit more. And that's the Tinkercad section. Then I have tons of stuff. So for example, I have YouTube videos on how to actually use the Slicer software. Go over to the 3D printing. These are all videos on how the printer is set up. So they can watch nice little short videos on how to load, filament, unload basics that way. This video is all around the Slicer, the Kiramoto, the web version Slicer. And this is Thingiverse and Tinkercad. I use how to find objects that are out there that you can pick to print, and they have to find something cool that they like and something useful that they like. Just like in the first one and the second one I showed, I do use Flipgrid. This time with my Flipgrid, I'm having them screen capture and show me what on the Tinkercad site and the Thingiverse site, the object they find, and they narrate it, and then they hand it in video-wise using Flipgrid. And I've talked about that. I'm going to do some specific tool-based trainings a little bit later as we go. And then we get into some prototyping and design, and we look at old videos on old cars, how they were prototyped, and then we look at new supercars that are how they prototype, and the difference between using clay models or the scanning that they can do now that they couldn't, and the 3D printing and that type of stuff where they can do that they couldn't, when the kids get to do that. And then we get into a section on different engineers, what their different engineer roles that are this is from Dyson Engineers, and the kids get a chance to do that. 3D printing is half of my trimester, and then the other half is all 3D modeling, where we're doing SketchUp and they're modeling their own house in 3D. And I'll come back and I'll show you more with this. Again, same thing. Here's where they hand it all in. So this is my clearinghouse for collecting the information, and we'll come back and forth to it. But that's how I do with Classroom, and that's my workflow with Classroom. Now, practical applications, I showed you forms. So this is how we hand the files in, this is how I get the information for them. This is how I collect it. I have some stuff that's automatically corrected as well. So I'm not having to babysit all the stuff too as well. And then practical applications, I use Google Earth, I use Tinkercad, and I use SketchUp. Google Earth goes along with SketchUp, and Tinkercad is for our 3D modeling. So I'm going to get into Tinkercad now itself. So let me show you some stuff around Tinkercad. So if I click this link, Tinkercad, it's going to open. So here is the Tinkercad website. You can log in, and you can, if you're an educator, you can use your school account and log in. The cool thing about using a school account is you can set up classes. So you can create a class, give it a thing, and then you can give the kid the link to join the class, or you can actually assign the kids. And what's nice is then you can go with so I made a 3D printing course. If I go into activities, I can add students, and I can add a new activity, say, oh, this is the tutorials, and I can put the activities right there so the kids get to them. The tutorials are pretty well done. I usually have them do a bunch of the first of the basics ones. There are about 12 basic tutorials that I have them do. Then they learn, on their own, and they hand in the work or screen capture of how they do it. For example, so this key letter chain one. So let's say we're going to go tinker this. Basically, they learn about the work plane. On the left-hand side of the tutorial, it shows them what to do. And on the right-hand side, it shows them the tools to use. And the work plane is here. And they learn how to spin the work floors, and I'll have to do a whole one just on Tinkercad with a little bit more detail. This is more just kind of the overview as we go, so you know what's out there. But they learn how to maneuver within the 3D world. This is very different because now we're working in a world that we've got to think about how we're doing it. So for example, if we choose like a letter and we pull it over, and there are different ways of grabbing it and pulling it. The problem in a 3D world is we can look and go, oh, that's all set, that's together. But when we zoom in and look out, we realize, oh, that's not actually touching it. So in this, we learn, in the tutorials, they learn how to manipulate this object. So how to make it bigger, smaller, make it hollow, make it different colors, make it different shapes. Why would you use hollow? Well, hollow lets you hollow out a shape. So if I come down here and I sit inside the shape, now that's going to hollow that out. If I group this, I'm going to take this and group this. What will happen is it will hollow the shape. So there's tons of different things you can do, and you can drag out different shapes, stack them, change sides, bevel it, tons of different tools. I will do a whole session just on 3D printing a little bit in Tinkercad. But the kids do the tutorials on their own, which teaches them all this basics, like how to move the object, how to add text, how to add different things to the object. And that's basically what they're doing. They're learning how to work in a three-dimensional world and how to provide that file that they have to make. They learn this. This is kind of a good one for them to learn, because in this they go and one of the make or take projects is a teacher's pass. So they learn how to make a teacher's pass, and you can see, so they can go and so they can change the text. And then they have a customer. They have to talk to the teacher about, okay, what size do you want this to be? How big? How small? What color do you want it to be? Because that's all matters on the printer. We also talk about, angles, scale. There's tons of stuff around this that we have to kind of get into. Now, then once they do, they have to learn how to get that file out of the software, how to export it to me, and learning what an STL is and OBJ and different formatting is, because STL is the file for 3D printing. OBJ are 3D printers, but the difference with those is STL is not going to tell you the different colors, where OBJ, when it comes, if you look, will tell me that this is white, this is yellow, so it gives more information. But they have to learn how to export that file and get that file to me so that we can learn how to do it. And I use Tinkercad. The tutorials are pretty great. So if I click on Tinkercad, Tinkercad has tons of tutorials. So if I click on Tinkercad and I say 3D designs, I can scroll down and there's tons of these different tutorials that they're showing you. Getting started tutorials are pretty good, right? There's also projects as a class. Like if you want, you can pick projects that are done, 3D design, circuitry. You can actually design in code blocks, which is literally designing using coding. It looks a lot like scratch coding, blocky coding, the coding that was in the Legos. So you can stack it and it will fill it in for you. There are classrooms, there's projects already done. So you can assign, like, oh, let's design a starter dice, design your own room, redesign the classroom furniture. And then you take that as a teacher and you give that to them, and it follows them through. There's tons of lessons too as well. Gallery, you can find products already made by people, and then you can edit it. So someone made this kind of like a Thomas the Tank one. You can click on it. Some will say copy and tinker, some say no derivatives. This teaches them a little bit about copyright and when can you. We'll hit copy and tinker this and bring it right in. This allows them, they've done the lesson plan, and then we talk about finding cool stuff that other people have already built. It's going to load, and you can see it's loading in. Let me just zoom out a whole bit. So you can see someone made these. then they can explode them and manipulate them and start playing around with them. So we start learning the tutorials. I have them do a keychain for themselves, and I have them do a teacher pass. And then that in that process, and we'll talk a little later, but that's where they learn how to load the filament and run 3D printers. Then they get a chance to go, okay, now find something for yourself if you've earned the print time. The more projects you do, or the harder the project is, the more print time you get. The easier the project is, or you don't do it, the less print time you get. And that's in Tinkercad. And that's this one right here. And again, I'll come back, and I'm going to have to do a whole session. I'm going to do a couple of shorter tool sessions just on each one of the software, because it will take quite a bit just to do that. But I'll do one on each one of these a little bit later. Now, once they've done a 3D object and they've gone and made a teacher pass, made an object for themselves, I then go, and what's going to happen to you is some kids are printing, and then like you'll have one, I have back-to-back 8th grade class that do this. So one class is printing, well, the next class come in, the printers are being used. So what I do is I have a kind of a off and on thing going. So the kids are doing the tutorials and they're making their passes. Once they have that, then I go and I have this 3D modeling project going on. So the kids learn how to design their own house to scale in SketchUp. And, you know, these are real jobs. My nephew works for a landscape company that he does a program all based kind of like SketchUp, and he designs landscape design, and it tells the company exactly what they're missing or not missing. So there's value in this, and I kind of show this. Plus, we do it to their own home because then it's connected to them. Now, basically, I use Google Earth. So I point out Google Earth is really intense for memory. So I do this, and then I go back out of it. I don't start there. So I have them search their address in this case. And if they have, sometimes kids like, my house isn't built yet, or I'm moving, I just have them do a school structure. It's not really, it's about having a real place that they would know about. So when we zoom out on it. It will take you to your place. So you can see this is a satellite. This actually isn't updated because that's the old high school, which is completely gone. And then we talk about how to zoom in and out, how to maneuver in this world. We talk about street view, kind of how does that work? How are they taking the pictures? How are they getting the street view? We learn about how to get in and out of street view. But you could see, oh, look at this. So the high school, this is more up to date than the satellite, because you can see the old high school is gone, the new school is there. Okay, we're going to zoom out. I'm going to hit escape and zoom right back out again. So I'm teaching the kids basic shapes and stuff. So you can see we'll line over. Usually what I do is I have them find their house. We kind of center on it, and then we do a screen capture of it, depending on the computer they're on. So we'll do a screen capture. I have them kind of center it where they are. And the same thing, I'll end up doing more detail on this program with SketchUp too as well. So now I have a screen capture of it. I can close out of this. I'm going to close out of both of them because they do. Now I'm back in here. And what we do, so that's the Google Earth. And then we go, so they get a screen capture of their house. Go into SketchUp. And we're going to bring their house in and use that here as well. Now I have a tutorial of this, so it's much more detailed. So if I'm going too fast on this, you could always go back to it. This is all around SketchUp. Again, I'll do PDs specifically on this. SketchUp has a free web version, so it doesn't matter Mac, PC, Windows, doesn't matter Chromebook. It's a web version. Same thing. It's pretty intense. Basically, the kids get a chance to open up a 3D model, and we start learning about orientation, how the tools work, orbiting tools versus pan tools versus zooming in and out. We talk about why is there an icon of this person there? Well, they're the average height person. So that gives you an idea to scale, because we talk about the kids like to build, will zoom so far in, they don't know where they are, or they'll zoom so far out that they don't know where they are as well. So they have to learn how to orientate themselves. And then in this case, they're learning X, Y, and Z axis. Now we've done that in Tinkercad because you need Z, the up and down axis, the back and forth, the left and right. They've had to learn that as well. And then with the kids, basically, I teach them a little bit of how to go and import. They go grab their screen capture. They bring an image in, and then they drag it. And again, they learn about scale, because in this program, if they don't know about scale, they won't know how to do this. So if we orbit it down, you can say, oh, okay, I've got this. Well, that guy is actually bigger than his foot is probably as big as one of those buses. That's my school bus garage, school buses. So that's not right to scale. So we learn how to, using scale tool, to scale objects, make them the right size. Again, how to orientate ourselves. They're used to playing computer games. They're used to doing that, but this is a little different where you need to be in a specific way. And a lot of times the computer games will lead you to places, and they have limits. They don't let you have outer edges. They direct you in a way, and they also train you as you go. So it's a little bit more intense for them to learn how to get themselves orientated in this 3D world. And they have to do things learning with the tools like, oh, the axes, I want to draw something, but I need to line it up on my structure. I don't want it, I want my axes lined up the right way. Drawing pencils versus rectangle. And if you, oh, okay, I'll grab a pencil, Mr. Kelly, and I'll draw my house. But when they get done drawing, they learn, oh, well, I can't draw, no matter how good I am, I'm not drawing a perfect rectangle. They learn how to raise and lower objects. And you can see, and oh, okay, height, and you can see scale becomes an issue. They learn how to work in this 3D world, how to make their own roofs. So I'm going through this fast. I know I'm going to go and do a training just on these specific tools, but so you can see that sort of stuff. If you look, so they have to learn how to manipulate this. Then they go, once they get to this basic, then they start filling things in, learning how to add materials and add coloring. And, oh, okay, my roof has this siding on the side, but this little building is brick. So they're learning how to do that. Oh, my roof, if we scroll down here, oh, roofing. I have single sheeter stakes, and I have metal roofing on this little object here. And so they're learning how to, and again, to scale. Then they learn some basic stuffs around the 3D warehouse, and how to go and find like a door. And they learn how companies put this stuff on there, and they're selling because they want you to use their big name companies put their stuff for free because they want you to use their equipment, or other people make models and stuff. And then we talk about finding the right one to our thing. So, oh, okay, I'm just going to download this door right into my project. And once they do this, they start to realize, oh, okay, how things are orientated does matter. And how do you move things? Because moving in a 3D world, this is one way to move. Moving up and down is another way. Moving back and forth, you're moving in different axes. Also, like, what if my object is upside down? How do I spin the object? How do I work with the object? How do I orientate it? And then how do I manipulate it? And how do I manipulate this whole house, like adding doors and windows and to scale? And this is a whole project that we do around the 3D. Now, this allows me, they're doing this while other kids are printing, and we're constantly rotating between who's doing what. When they're done, they can save it as, they download it, give it to me as a SketchUp file or a picture file. Or they can even give me STL, so they can actually take something and make a file that will be able to go to the 3D printer and print too. So we're adding that scalability of being able to manipulate and make our own objects from nothing too as well. As you can see how I've done this, so we've got the modeling going on. So they're either making objects for the 3D printer, they're printing on a 3D printer, or they're making models of their own house to scale. And that actually gives them something that connect with the parents. I have them go home, talk about size. They start to understand standards. Why are doors a certain size? Why are there 10-foot ceilings? And that gives them an idea of scale. Now, 3D printing in the classroom, we go and I have to teach them the basics of how to take an object and how to print it. So now the 3D printing basics that I do with them, I teach them additive printing, subtractive printing, additive where you add material, or you subtractive, you cut it out. And this is also goes later on for CNC and laser, that type of stuff later. We go over the kind of the major parts of the printer. We talk about filament, where it goes, how you load it, the controls. The kids get a chance to talk about the build plate, like how adhesion, glues, heated versus non-heated. How do you set that up for it to be a successful print using rafts, using not? Some have cameras, the extruder, how does that filament, how does that whole system work? That little motor, we go and take one apart and we look at it to see why is that made like it is. And then we talk about how to get print jobs there. They might be mobile. We might be go and grab a file, passing it different ways. Talk to them tons about filament, PLA, plant-based, basically corn sugar, that type of stuff, versus the ABS, which is more petroleum, flexible, heated. And we do get talking about nylon and titanium print, powdered printing, other styles of printing. In my school, we pretty much have PLA for them. There is a few printers for that higher level kid, for our older kids doing a project, but most time PLA is perfectly fine for what the kids are doing. They have to go through all the steps of the printing. They learn how to level that plate. They learn how to load the filament, unload and load it. They learn how to pick their project, adjust it. They learn how do you get it? They learn how to take it from after making it or adjusting it, bringing it into a slicer program and setting it up for the print. And then they actually do it. I step back, they load the print, they do the whole file. And then they work with their customer, and they have to decide, like they trust it. It didn't stick to the plate, Mr. Kelly. Okay, let's add a raft. And they learn a lot of troubleshooting this way. Now, file formats, the big two we do is STL or OBJ. STL is the standard pretty much. OBJ, the only real big difference is if you have a printer with a dual extruder, not just one, you could say, print when it has the different colors, pause and change the print extruder. We don't. Most of the time, I'm not having kids do that. So we do it in STLs. They've been doing the tutorials. Some kids, we start on the printers, they're learning the setups. Then there's a point where we flip. Some kids are printing, some kids are working on the 3D modeling of their house. They're setting that back and forth. They learn how to do some slicer G-code software. Flash print is and Ultimaker Cura. It comes with the printers, and there's tons of different printers. Cura is kind of the standard. You have to have a Mac or PC for those to run. Curamoto is a web-based one. So if you don't have a Mac or PC, Curamoto will be one for you too as well if you have that. So Flash print, you download, and in this, you'll learn how to maneuver an object. Now, the kids have to learn with this stuff is they're not manipulating the object. They can't, after the fact, go, I need to make that one stack a little bit taller, or I need to go and I need to cut off that top piece off that. You can't edit it. You're not editing it in this program. You're editing it in Tinkercad or SketchUp or another program. And then you're bringing it, all you're really doing here is making this setup for the printer. So make sure it's not going below the build plate. Make sure it's the right size. Make sure if you need a raft, so it doesn't slide off it. To pause, so it would change colors. Because you could say the bottom of the boat is a certain color. When it gets a certain part, pause, and then you change filament. And then when it gets to the stack, pause and change. So you can tell that all in this software. Cura is the same thing. Cura and Flash, are from the companies you can download, but you need a Apple or Windows for that. There is Curamoto, which is a web-based version. So if we open this up, so I have to teach the kid this. I have, again, in classroom, I have a whole video around this. The kids have to learn how to set up their printer, adding the printer, because this, for example, this print plate is really large. They go and set up, and they learn like machines. Okay, I got to grab the machine that matches my printer. and then they can go, oh, okay, and they say, oh, now the print service, and if you don't make that fix, it's gonna make the machine not work. It's gonna try to go past where the extruder is, a whole bunch of stuff. So then what happens is they learn all about different characteristics of 3D objects. They learn about infill. If we look at an object, and I'm just going to move this, you can see this object. They learn how to go and like import one of their teacher passes. So I'm going to go out. This is one of my students' teacher passes. So that's the Mr. Kelly teacher pass. So you can see I can move it. So I'm going to go over here. So I can move it on the work plane. I can't edit it. Like I'm not gonna be able to change, say they spelt my name wrong, or I can't change it. I can't move this whole. I could do some limited things. I can go over and you can play around with like infill, like how solid it is. You can add rafting. Oh, layers, here we go. You can add, okay, I want it thicker. I'm going to enable the raft. So when it prints, it will print a raft. There's tons of settings. I talk about the kids. We go through these kind of different simple settings. We don't really do a lot of, too detailed with them, but we go in and we mess around with the settings. So they learn how to bring the file in. They learn how to slice the file. We do some stuff around learning how to, for example, like rotating. So you can see, we want to make sure like we're learning about printing going, oh, well, maybe that's not the best way to print that object. We might need rafting. We might, oh, you know what, we're going to try to make sure that this is laid flat down. And we wouldn't want to, we want to print it in the best way for it to be able to print. So you can see like, that's not going to print right. It's going to hang. And I go over the kids that way. Like, well, what happens if you mess up the print job? So you can see now we're printing like this on the side, and then I have to talk to the kids. Okay, so see those letters, they're going to hang out, we might have to add raft or tree supports or that sort of stuff with it. So there is a learning curve with this thing for the kids. And I will break these down individually. So I'll do a Tinkercad PD, I'll do a SketchUp PD, I'll do a slicing PD, or kind of a 3D print PD, just for the sake to help you out, because it is pretty intense. Now, that's so you can orientate it. So a lot of times they come in pretty close. Then we talk about, so I'm going to hit slice, and what that's doing is when you have 3D or CNC, it's just slicing. It's doing a layer on top of a layer on top of a layer, and then you can kind of see. And if I do this, you'll see it's showing you, okay, this print job, when it prints, it's going to do this base layer. That's your rafting. Then it's got some honeycombing happening, and then it starts to doing just the letter. Now, with the kids, we learn how to pause this print job. So when it starts doing just like my name, my letters of my name, we can go and have it pause, change the filament. So the base of the keychain will be one color, and then the rest of it will be a different color. So that's the way to do two colors, because we're linear. We're not jumping back and forth. You can't. It'd be hard to go up the side of an object. And we talk all the way through this, and we learn about all this. And then when we're done, we learn how to export that file out to be G-code so that we can then take it to the printer. Kids have gone and learned how to once you get that file, they've learned how to take it and bring it into the slicer, and they learn how to view it and change its position and rotate it and scale it like they want. And then they learn how to print that off and send that to the printer. And they can either do it Wi-Fi, or you can have like a USB keychain or a 3D an SD card, depending on the printer, how it works. I do a lot of sneaker net. What I mean by that is a lot of USB, so that print off just don't happen. The kids have to think it through to get it to the printer. Again, you can do this stuff virtually. You can control these objects. If you're doing a long, huge project, you do want to use your mobile device, because you can actually set the camera and watch it to make sure the print's not messed up. I've had tons of times with custodians, I tell them, while you're working, if you notice the print job messing up, just turn it off and pause it. The newer printers are much better. If they don't work, they will, and you pause, stop, they turn off, they'll just start right exactly wherever you left. The older ones, you're out. If they run out of filament, run out of filament. New technology is happening. I'll be doing this with older kids. And when I talk about my older sessions, we'll talk about this in a little bit more detail, but they do have the new Apple iPhones have LiDAR built right in. So they can scan. There's some more work to that setup, but they can scan the object, take a picture of themselves and then put it in. And where long-term, like my older kids will work on making action figures of themselves. There is some problems in this when you're talking about 3D printing. You have tons of, the possibilities are insane. You can print cars, food, metal, tons of stuff. When you first get a printer, first you'll be like, what am I going to print? And then you'll be like, oh, I could print all day long. And it's gotten a lot better. There's a lot more choice. When we first started this, you had to make most of your own files. So there's really kind of high level stuff that you can do from replacement prosthetics. And now you can do it in a cheap enough way. Prosthetics that used to cost $10,000-$20,000 are now in the $5,000 to $2,000 range. So there's really cool projects out there. I'll take my kids through, and I'll give you the slideshow on my website. So if you want to watch the videos, you'll have them too as well. These are great ones to show the kids. This young boy, Dad printed out his own prosthetics. The cool thing about that is he can make it specific for him. He has one to ride a bike, one to play baseball. He couldn't do that on the price point of the old way. The above one is an eagle lost its beak, so they 3D printed one to replace it, so it helped it for eating purposes. They have food. Anything can come out of the extruder, so you can do foods out of there, like chocolate design, things of that nature, noodles, stuff of that nature. So you can add some kind of, and then what you can do is make stuff automated that way. Cars, they're definitely doing all the supercars now. What they're doing is in the design, they're 3D printing the objects to before they used to, a lot of times you would make them. Now they can 3D print them and test them all out in the winter, in how it works before you actually have to. They're actually getting to the point with the supercars that they're actually printing the file and it's going right on the car. The reason that is lightweightness. You can really make it light, and you can also do some design. So everything it's built inside, like turbos and things. Everything's going to be redesigned. And again, I'll have these videos for you. You can print in metal. You can print replacement parts. You can print stuff that like you can't get anymore that you can only do on a printer. There are problems. It can be expensive. It's gotten way down. Printers at first were in the $2,000, $3,000, depending how fancy you get. Now, if those are your fancier ones, you can get a base entry-level $400 3D printer. Getting in, and as a teacher, what you're going to find, it's not about having one printer, it's about having a whole bunch of printers. So you're better off to spend less and get a whole bunch of printers than spend more and just get one. Safety, you have hot nozzles, moving parts, removing parts, stuff like that. Most of my kids are pretty good. You're going to get a pinch or a burn. They would have to be not being safe to do it. Fumes, you've got to be careful if you're using ABS, stuff of that nature, and copyright, and you can make anything, so you have to be careful. You can print something on there. I've had I went to one school and they printed a knife. Well, the only way that happens is that's a whole day print, so I got left to do. So there's an issue. You've got to be thinking about what the kids. A lot of times there's so many good things they'll want to print. They don't want to print the silly stuff. They want to print a phone case or something of that nature. That's what they're looking to do. There's tons of these resources. There's tons of different software out there. SketchUp's the big one I use, Tinkercad. But then you have MeshLab and Sculpteo, and they get more specific to what you're trying to do. So if you look at the course as like in this way, you have levels of 3D projects. You have participation type projects, which literally are, I go to Thingiverse, I find something, I print it. I'm not manipulating, I'm not doing anything to it. I'm just finding something already done and I'm just printing it. So SketchUp 3D Warehouse, Thingiverse, Tinkercad has a gallery. So you can find something. This is a lot better. When we first started doing this, there was very few objects, so they couldn't. But you can go find. Now, the only problem is someone else made it. Doesn't necessarily mean it's set up for what you want. It's not set to your scale, to the things you want, or it might be a bad print. It might not be set up right. So there is that issue. The next level is the process. So they get a project, and instead of just
going right to the printer, they manipulate it. There are customizers out, like there's a ring customizer, so you can go in and just you type the text and you say the size, and it does everything else for you. Tinkercad has some of that too, where you can take a model already done, edit that model, so you're not starting from scratch. You're saying, oh, I want a phone case for my iPhone or my Samsung phone. So I go grab it, I find one that's like it, and then I can manipulate from there. Prototyping is now you're going to the next level where you're trying to create something, test it out. The big thing with prototyping that's interesting with kids is they're so used to stuff costing a lot of money, and they're so used to, they don't understand, like kids will print something, go, oh, Mr. Kelly, my print job messed up, and they'll think, oh, that's a horrible thing. And a lot of times you're talking pennies being used in material. Roll of material costs you about $20 or $15. If you really look at how much stuff is being printed, it's your time is your value. That's your commodity, not the actual filament, even the printer. It's the time that's the most valuable. So again, SketchUp, my kids, we talked about this project where they go satellite, build a house, and then we get it in and they actually can print it too. So, and prototyping will add, I'll show you some samples where we're actually, it starts to matter. It's not just, oh, I print it or I did that project for Mr. Kelly, but it actually matters how it works. And produce, that's the level, another level, which now you actually have to have something that works. You design the product, you model it in the thing, you get it on the printer, you print it, then you actually have the file, then you actually have to assemble it, and stuff has to fit. The motors have to fit, the propellers have to fit, weight matters, location matters, balance on this object, and then you actually go and use this object. So you have something that's an actual working thing, or someone's asked you for it and it actually has to work. So necessity comes from, you actually need the item. It's not just for a teacher or grade. It's not just a one-off product. We're going to use it. We're going to redo it. And again, we use tons of different modeling software to do this. There's tons of different programs out there that you can manipulate, find things, and edit things on. We use the Flashforge binders. They're the cheapest kind of one, that's the most ready. There are others. Ultimaker has some too. We have some Ultimakers that have 2 extruders, so we kind of have a couple that are at kind of higher level. You get to it basically with printers, you get the entry level, then you get the next level where they have heated plates. Then they start adding features of, a camera, or if the power goes off, it will stop, or if you run out of material, it will pause it, so you don't just have a wasted print job. There are cheaper printers. You just got to be very careful. Some, like, you get in parts and you assemble, and that's great, but that would be more my higher level kids too as well. So the make or take, they could be tons of different. Over the years, I've built up things, table parts, mass hooks, teacher passes. What will happen? I just had my AD come to me because little clips off the bleachers were taken off that hold a certain thing. So we're printing him some of those right now. So all through the year, people will ask for things. So here's some examples. So we had these lunchroom tables that fold up. And in this corner, there's this little plastic part that literally just broke in half. You can't buy that. Those tables are, they just fall apart. They don't hold together. So again, one of the kids went in, took calipers, did measurements, went into SketchUp, made the file. We sent the STL, we tested, printed. You can see we have multiple prints of the blue, the white, the red. Those are until we finally got the part. Now we can print 100 of those. The principal was so happy. The principal bought us filament, was all excited because now we took that. And that happens tons through the school. Custodians will come and ask for clips and things to me all the time. Some higher level stuff. We had a young girl that was homebound, and she came virtually, kind of like a Shellbot you hear from the Big Bang Theory. So basically, that is an iPad on a basically a Segway. It rolls around, so it goes around the school. She sits at home, and you see her face, and she walks up and she can talk to the kids, and it's great. The only issue is the kids got used to it. It's going in the hall. It's so thin and narrow. Well, the girls notice that. So, and it's also kind of not personal. So what they did is they went in, did some measurements, find out how to make this triangle thing that sits in on the holder, and it could hold a t-shirt to kind of give some personality. Then it was funny because they then went and added some pieces, like a unit that would let it go. So back then you could put a Wi-Fi, or we could have a phone in it that would give it Wi-Fi signal, so she could actually go on field trips with us. So it was kind of a project that came from, a real thing. The girl got to use it. They got to see her, talk to her, and then they had to build it, and they kept changing it. Actually, in the end, the company came and really liked it and took their files and did some stuff with them too as well. Here's a video if you want to watch more about that too as well. Prosthetics. I have a former student that was born with no hand, no feet. He was in the Olympics. Yeah, and he needed prosthetic blocks coming out. So a student was working on that for him, very specific. He had a daughter. So the daughter, to understand dad, we had one of our students create a toy that looked like dad based on dad. We were trying to make, so we're in the process of making some dolls so that girls that or boys that have, or action figures that girls and boys that have no leg, we printed a 3D prosthetic. We're putting it on so that it looked like them, so they could have a doll that looked like them. Then you can get higher level. I get requested for things. For example, this is a classic Mustang. This shifter handle, this little part inside of it breaks. You can't buy for this version. You can't buy a replacement one. You can buy a newer one, a different era. So if someone wants it accurate, so the kid went in and designed this all in 3D, and then we 3D printed them as well. There's tons of very practical. So found objects. So, okay, Mr. Kelly, you have these Black & Decker work benches that the kids snap the little handles off. The kid, they come up to me and say, Mr. Kelly, I want a project. Say, okay, go find that and print it. So they didn't do anything. They just found it, printed it. What's interesting, once you do that, we find, well, that same handle constantly snaps. Okay, can we find or redesign something to make the issue of why it's snapping not? So that kind of leads. But the first thing is just something found that you go and print. The second is you customize something. You're taking something and you're just doing a few limited variables, and there you go. We do that with teacher passes and stuff. I showed you that keychain that you saw. We just add some lettering and there we go. We're not actually doing much more than that little customizing. We're not creating it from nothing. Then you can edit an existing object. So this design hand, the student went in, design. So what if instead of having just a one thumb connector, let's add, so can we have two thumbs on each side? And this one is all run through little sensors, and it reads the electricity in your arm. You squeeze it, it would squeeze. So they played around with it. So they took something that was already done and they added to it. And then create objects completely. So we have a kind of a cool little project where our older kids go down to the younger kids, they draw their hand. We've all done that Thanksgiving where the kid draw and then, the hand, and then they have the Thanksgiving object. Well, this one, they draw on a piece of paper, they took a picture of it, and then you go and that gets printed and they gave it to their parents. And then you start to get to reinventing or impossible objects. One thing that's going to happen is everything's going to be able to be redesigned. We have pistons in a car because you need, and they have a little O-ring around them because assembly, you have to have that to fit. Well, with 3D printing, you're getting to the point where you can actually print stuff all in place and really, really, really close. And so that you can just have replacement. Then you have an object you can't do. This is a digital sundial. So as you use it as a sundial, you can see it says 1248. It tells you the actual number from the shading. It's all done, printed. It's layered. It would be very difficult to do in drilling or cutting. It's something that kind of an impossible object, or like the ball inside a box already there. That wasn't added laughter. It was built as it went. So plan, prototype, produce. The kids we kind of take them through this options as we go. And then again, as the higher level, the kids can use higher level printers. So in my SketchUp model, the kid takes their house, grabs a satellite, designs it, brings it in, and then we end up printing it. They manufacture, they apply their knowledge through effort and reiteration. And that makes makers. And this young man made this is an RC snowmobile, all from 3D printing, a little bit higher level. So as I said, we're still doing science. They're learning material properties, machine setup, all that sort of stuff. They learn technology because they're learning tons of modeling, software, and design, which is very different. They learn engineering, so material and structure start to matter, like tolerances. That tube has to fit in a certain spot if it's too big, and then strength of it. That's an engineering and design. Now, how much infill do we have? Do we make it solid? Do we make it honeycomb? We are doing English. They're reading. There's tons of technical type reading in this, following the menus, that type of stuff. Art, there's coloring in the modeling and adding materials. And again, this is a higher level, and we'll do this later on in my higher level ones, where you go from like elegant design becomes an issue, like not just designing an object, like making it work. The girls found when they made this, they went, oh, we need to redesign it to hold a holder for the Wi-Fi, like, so it's constantly being added to. Math, there's tons of scale measurements. We're doing learning X, Y, Z axis, which actually helps them when they're doing graphing, because now you're at, oh, okay, I understand why we're doing that. So basically, that's the concept of design in this program. So that was learn from necessity. So stuff where there's a problem, like this sign we had, it was the salt kept hitting it, taking on. They had the typical, so the kids went and we used our CNC machine and we carved our own and we replaced it. So we had a need, we found it, we fixed it, and we replaced it. Now, my next one I will do is learning from consequences, and we're going to talk more about that, where now we're talking about the object has to work, and if it breaks, there would be a problem because of it. And we'll come back to that. I am going to do more of a section on tools, so I'm going to go back and do one shorter ones, probably 30-minute ones, so short ones, but all on that tool, like video editing, Flipgrid, WeVideo, and then I'll do like this, like a one on Tinkercad, a one on SketchUp, a one on like different tools, as we have one on Classroom or on to that. Thank you very much for coming. Again, all of this is on steammakers.education. The PDs are there. Give me about 2 or 3 days in this video. It will be up there, posted. I put the slide deck there, so if you saw stuff in the slide, there's videos that you can watch that can go great to show with the students. I have, if you're interested, I can have Classroom set up. So if you're interested in seeing the Classroom files set up as well, I can access to. I'm adding to the curriculum and putting the curriculum down as we go. I'm adding resources. There's a resource link. And the newsletters, if you want, you can sign up for MailChimp and the DOE, and you'll get every week, well, 3 times a week, 4 times a week, depending on the schedule of the holidays and everything. You'll get a mailing from me, and it usually will be helpful resources, what we're going to talk about, where to find some of these tools. And so far, I've done what I do in 5th, 6th, 7th, and 8th, basically collaboration, communication, production, and I just did design. And then we'll go and talk about more as we go. I'll keep adding them throughout the entire school year. The Google form is there if you're interested in giving me some feedback, saying, oh, I really wish you would do a training on this tool. Talk more about this, and or I might be missing something, or something you know about that I don't. So I put the link right there. And again, this link is if you go to the PD section of steammakers.education, scroll to the bottom, this link is active right there too as well. Thank you very much. And I will see you later.